Today's show is brought to you by MongoDB. No one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or API calls. MongoDB Atlas automates deployment, updates, scaling, and more so that you can focus on your application instead of taking care of your database. You can get started for free at mongodb.com/atlas. If you're already running a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime, then get back to what matters. Stop managing your database and start using MongoDB Atlas.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody's doing well. We are continuing to move through February, the year, first year of the decade, 2020, continues to roll by. Hope everybody's doing well. Let's dive right into Cloud News of the Week. A couple of interesting announcements and some things of interest to a lot of different people. First one is kind of a continuation of cloud earnings numbers coming out. We talked about Google being around 2 point something for the quarter, 2 point something billion for the quarter, putting them around 8.9 billion or so. Amazon AWS announcing around a $10 billion quarter, putting them around $40 billion annually. Microsoft coming in around 20-something billion. Their numbers are, again, we talked about trying to sort those out. And then Alibaba announced their cloud earnings numbers. Alibaba Cloud announcing about $1.5 billion quarter, about 62% growth, so puts them around a $6 billion cloud. So very interesting to sort of see all the major clouds now. IBM announced around 21 billion as an annual revenue number. Microsoft around 25 or 30 billion. AWS around 40 billion. Google around 10 billion, and Alibaba around 6 billion. So, the five big clouds kind of all, beginning to separate themselves a little bit, some of the biggers from the smallers, but it is always interesting to sort of track that, see where their growth is. I do want to do a little bit of homework and look at different growth rates at different revenue numbers, but always good to see more and more transparency from the different cloud providers. A second thing that will be of interest to some people, especially those who kind of are watching what's going on in the bigger clouds and some of the more critical clouds, the U.S. federal courts have put a temporary hold on the JEDI contract. The JEDI contract was the one that a lot of controversy around for the U.S. Department of Defense. About a $10 billion contract over 10 years was awarded to Microsoft Azure. As expected, Amazon and AWS have sort of filed a suit in court about how that selection process went on, and so that process is now on hold. Will be interesting to sort of watch this unfold as to whether or not it will be driven by technology, by politics, or a lot of things in between. GitHub, a company that we're very, very interested in because we think they're doing some pretty interesting things, rolled out a new capability called GitHub CLI. So essentially extending the GitHub capabilities out to your individual machine. Again, sort of extending all the different ways that they're going to interact with developers. So that moves into beta. And the last thing, just kind of a heads up for people. I know a lot of the people who listen to the show at some point are attending events around the world. We are beginning to see the effects of the coronavirus starting to have some impact on some of the major events. As we may have noted last week, the Mobile World Congress event, one of the largest in the world, was canceled. Typically is in Barcelona, was canceled. We are beginning to see, a few of the events in Asia be canceled, where people are traveling to there. And then, kind of a heads up for people, if you are attending an event, just be very, very cautious about reading the cancellation policies, both for your tickets for the event, as well as any sort of, travel and expense that goes along with that, whether those are airline tickets or hotels and so forth. Not trying to make any prognostications about, how events around the world will continue, but as we do begin to see the coronavirus spread and grow, unfortunately, that will have some impacts as to whether or not events continue to happen, whether people are concerned about the events. So just kind of protect yourself and make sure you understand any cancellation policies and anything that may affect your ability to either travel safely, or potentially get reimbursed if those events don't happen. So with that, we're going to wrap up Cloud News of the Week. As we mentioned, a couple of different things. I think we're very excited about the next conversation we're going to have. We'd love to dive into not only databases, but also some other interesting scalable technologies around those. So with that, we are going to talk about scalable databases right after the break. Today's Cloudcast is sponsored by Datadog, a cloud scale monitoring service that provides comprehensive visibility into cloud, hybrid, and multi-cloud environments with over 350 integrations. Datadog unifies your metrics, logs, and distributed request traces in one platform so that you can investigate and troubleshoot issues across every layer of your stack. Use Datadog's rich, customizable dashboards and algorithmic alerts to ensure redundancy across multi-cloud deployments and monitor cloud migrations in real time. Try Datadog for yourself with a free trial, and you receive a complimentary t-shirt. That 14-day trial can be found just by going to datadog.com/cloudcast. That's datadog.com/cloudcast. And we're back. And folks, as you know, if you've been listening to the show for a little while, one of the topics that we really love to dive into all the time is kind of the breadth of database technologies that are out there and the huge amount of innovation that's happening in this space. And then, obviously, if we get a chance to talk about things that are near and dear to my heart, like Kubernetes, and we can combine those things together, that is always kind of a great combination for an interesting show. So very, very excited today to have Peter Mattis, who is the co-founder and CEO of Cockroach Labs. Peter, welcome to the show.
Glad to be here. I'm actually only the CTO, not the CEO.
Oh, I'm sorry. I have that in my notes, and I just read completely over it. So, but co-founder and CTO, not only Cockroach Labs, but also kind of the inventor of the Cockroach database. For folks that may not be familiar with your work or some of the things that you've done, give us a little brief kind of introduction to some of the work you've done in the past around distributed systems and what's gotten you kind of really passionate about this space.
Yeah. So I started off, I joined Google a long time ago, back in 2002. And when I first got there, they were working on an internal project to provide search around email that eventually evolved into being Gmail. So I was involved in Gmail very, very early on,
Wow.
Helping design and implement the backend search and storage system for Gmail. So that was super fun. Working on Gmail got me intimately involved in the distributed file system Google had internally called GFS. That was the first version of their distributed file system. And at some point, they started working on a second version, and I became, one of the key contributors early on to the design of that second generation distributed file system called Colossus, which is still in use throughout Google. I think it underpins all data storage at Google nowadays. And during that time, working on Colossus, there's also some sister projects. I worked with the Bigtable team, which is one of the, Bigtable's one of the early NoSQL systems. It's only available internally inside Google. And Bigtable is actually used by Colossus, but Bigtable also runs on the Colossus. And that kind of weird chicken egg scenario of how that worked was actually my doing, which is I look back at it both with a measure of pride and measure of shame that I managed to make that kind of monstrosity possible.
Yeah.
And I was also sister team working on Colossus is right next door to the Spanner team. So I saw Spanner, which is Google's distributed SQL database being built. And I saw a lot of the reasons why that was happening. Around that time, I left Google and went on and eventually landed, did a startup in between, landed at Square, and saw some of the challenges they were having with big data there.
Yeah, no, that's a fantastic set of work that you've been on, and it's always cool to get to meet people that work on things that you just unfortunately sort of take for granted every day, right? We get to take advantage of Gmail and all the wonderful things that Google does. So very, very cool. Like I mentioned in the intro, we're gonna kind of mash together a couple of complicated topics, but are becoming very popular, both people needing to manage not only large amounts of data, but distributed data, as well as Kubernetes. Why don't we start with the data side of things? Give us some background on CockroachDB, your creation, and kind of some of the things that drove you to want to create it, as well as the project around it.
Yeah, so CockroachDB, the one-liner is it's a geo-distributed, horizontally scalable SQL database. So let me unpack why we created it in the first place. So when we left Google, myself and my co-founders, we kind of were looking at the data landscape out there and what we wanted to build on top of. And we were looking at the SQL databases, the kind of legacy monolithic SQL databases, and those are super popular. People love using them. And the reason application developers love using them is because they generally work really well.
Yep.
Except if you get to a certain scale. And you get to a certain scale, and then you have to shard. And sharding means, you make multiple copies of your database, and you take care to arrange your data so that, your application itself is sharded. It knows which shard to talk to. If you ever have to do anything cross shards, it's very, very painful. And we saw that pain played out at Google over and over. We saw it played out when we got to Square, and they were trying to shard their MySQL database. Pretty much every successful technology startup deals with this sharding problem. It
Right.
puts a huge amount of burden on the application developers. Then on the other side of the database spectrum, there's all these NoSQL systems. And the NoSQL systems were like, hey, we're going to eschew all that kind of wonderfulness that makes developing applications wonderful, but we're going to give you horizontal scalability. And they generally kind of achieved it, though they threw out, indexes, transactions, all sorts of the nice declarative SQL language. And so they kind of achieved their goal, but they also placed a huge burden on application developers. And I've seen numerous times applications reinventing transactions at the application level. We thought that was absolutely the wrong place to do it. So what we tried to achieve with CockroachDB is the best of both worlds: horizontal scalability, like you see in a NoSQL system, along with the transactions, the indexes, the rich query language that you find in a SQL database.
Yeah, interesting. You're taking the trade-offs that a lot of the other ones sort of chose to make, and like you said, you're kind of getting rid of them. Given the scale that people will eventually get to, right? Maybe you don't have it initially, but you'll eventually get to. Are you finding that more and more people are foregoing some of the, like you said, sort of the traditional SQL databases and starting with Cockroach and saying, oh, well, I don't have to worry about that thing down the road? Is that kind of the mindset, or do you find certain use cases are more applicable to Cockroach as a starting point?
Well, that's absolutely the mindset we want people to have. I mean, we designed Cockroach, our flippant remark when we were starting off is we wanted to build a database that we would use at our next startup. Mm-hmm. I don't think there's ever going to be a next startup for me after this, but CockroachDB, I think, is fulfilling that. There's no reason you would need to get started on a legacy SQL database now. It solves all these problems, even at a small scale, of providing reliability and availability. And even if you're a small startup and you have relatively modest data needs, you still might want to configure stuff so that you can survive a, AWS region failure, for example. And doing that setup with something like Postgres or MySQL is painful. With Cockroach, it kind of just comes out of the box, and it's super easy. When you actually do start to want to scale up and you need to get larger than a single Postgres or MySQL instance, CockroachDB just smoothly scales up with you.
Yeah, that makes a ton of sense, and it's nice to know you sort of have future proofing built in. We also mentioned in the introduction we were going to hit on Kubernetes, and what's interesting, and I've been around the Kubernetes community now for 4 or 5 years. I know you've been around it for partially from Google days and now these days. When it got started, it was, mostly focused on, scalable stateless applications, building new things. We're seeing this trend more and more around how do I bring stateful applications and the databases to Kubernetes? What are some of the things that you're seeing, as you're intimately involved with this, that's driving that trend towards more just broader use cases to Kubernetes?
Well, I think the major one is people are just realizing how wonderful it is to manage your application in Kubernetes versus doing it outside of it. In Kubernetes, don't get me wrong, it's super complex, but what's more complex is not having Kubernetes there and having to do that all manually. And, as soon as people start getting exposure to running their stateless service in Kubernetes, they're like, well, I want to do this for my database. I want to do this for my other, data storage systems. And trying to make sure that those things worked well within Kubernetes has been the challenge of the last couple of years. Stateful sets are something that's been in development for a long period of time. Then, we actually had some input into what was being built there because we were one of the early databases trying to get working on Kubernetes.
Hmm. Yeah. One of the things that we've seen emerge, Kubernetes by itself wasn't terribly application aware. We've seen this trend around, starting with the operator framework that CoreOS initiated. We've seen, operators and community operators grow. Is that a capability, Kubernetes operators that you're involved in, that Cockroach has an operator that's out on operatorhub.io today. Are you finding that technology is helpful in not only making it easier to deploy the databases, but bring some lifecycle management to it? Or is there still a lot of work that needs to be done?
I mean, it's certainly, I can't speak too directly about what needs to be done for the operator framework. Mm-hmm. We are actually actively putting efforts into improving our operator. Mm-hmm. Certainly it helps with lifecycle management. So we very early on, it's interesting, like Kubernetes and Cockroach kind of came into existence around the same time. Yep. We didn't actually know that Kubernetes was going to spring out of Google at that time. I came from, having used Borg extensively inside Google as a user, and it was just wonderful not having to worry about machines and all that orchestration. And then we got outside of Google and we're like, ooh, this kind of stinks. Well, what we're going to do, because we don't have Borg here for us to orchestrate our systems, we're going to just make it so CockroachDB is super easy to use. And we generally kind of achieved that design goal. There's a single binary binary, that single binary can adopt multiple roles, but you don't have to worry about orchestrating separate systems and whatnot. That's one of the reasons Cockroach works really well inside Kubernetes, is it's so easy to administer outside of Kubernetes.
Gotcha.
And yet there's still needs that, there's still operations, administrative operations you want to do with Kubernetes and Cockroach, such as, taking a node out of service and replacing it, or growing a cluster and whatnot. And right now it's like pretty easy to grow a CockroachDB cluster. You just add another node onto the cluster, but the operator just makes that even more turnkey, where you're just doing this edit cluster operation, say add another node, or, take down this node and replace it with a more powerful node.
Yeah.
And those things are all kind of, possible and straightforward to do with Cockroach, but it still requires kind of more administrative effort than you'd really desire.
Right. Yeah. And I think you highlighted something which is always interesting. Timing is always an important factor in technology. And like you said, Cockroach sort of came along when Kubernetes came along. So the lessons that the Kubernetes community has been learning, I assume you've had input, because it's open source, to helping with, but also it probably shapes a little bit of how you've built the product, like you said, for ease of use, ease of deployment, ease of administration. Are you seeing that as the case, or are they just sort of running in parallel and the timing has worked out really well?
Well, I mean, there certainly was a bit of running in parallel early on, but, I'm actually kind of shocked. When we started Cockroach Labs 5 years ago, we're getting started with CockroachDB, Kubernetes wasn't even known. And we're like, oh, what are going to be like the major deployment, scenarios for CockroachDB? And we're thinking about them. Then like 2 years down the line, Kubernetes coming off, we start paying attention to it. I don't actually know what the number is right now, but the majority of our clusters, CockroachDB clusters, they're deployed on Kubernetes.
Interesting.
And so we take advantage of that. We go and, improve our operator, make the experience smoother. Our Cockroach Cloud service that we offer, CockroachDB as a service, we're running that. Those Cockroach clusters, they're running on Kubernetes, because we found Kubernetes to be the easiest way to manage the clusters ourselves. And part of that is, also one of these awesome things that Kubernetes provides is this abstraction away from the specific cloud, idiosyncrasies, and doesn't completely do it, but does it to such a degree that when I talk to that Cockroach Cloud team, they're just like, yeah, as soon as we get the Kubernetes bits running in there, it's great. The challenge is, dealing with all the stuff that's outside of Kubernetes for these various different cloud systems.
Right. Well, and I can imagine, I mean, you talk about the Kubernetes abstraction. That's obviously very powerful. It lets Kubernetes run fairly consistently anywhere it runs, on premises in the public cloud. And then the nice thing about operators, for people that are maybe new to this, is operators in essence say, let's take the best of the day one and day two of that application. So all the smarts that your team knows, you can build around that operator. And the nice thing is, now that operator is going to run exactly the same no matter which Kubernetes it's in. So you get sort of portability plus consistency. It's a powerful combination.
Agreed.
Yeah. Real quick, like as Cockroach has grown up, kind of like you said, in parallel with Kubernetes, but you're seeing it used more and more frequently. What are some of the lessons that you've learned, or some of your customers have learned about running stateful and scalable SQL on Kubernetes?
Let me think about this. Kind of the lesson I'm seeing develop over time is that people want to be abstracted away from machines more and more.
Right.
And cloud systems did this. The cloud did this initially. When was the last time you actually saw a machine in a data center? I've seen pictures of them, but I haven't been near those in a decade. And I feel like Kubernetes is taking this a step further, abstracting us away from the machines. And I just see this continuing. So this isn't so much like an active lesson that customers are coming up saying like, oh, I'm so glad you abstracted us away from, the machine or the node. This is where I see like kind of the industry going, even like almost beyond Kubernetes, where I can just start thinking about like, oh, I just want services in the cloud and I want services in this region, that region. The details about it being a node, we'll leave that to some SRE team to figure out. I can see that is where the future is going. And Kubernetes is a big leg up in helping get there.
Yeah, and do you find on the SQL side of things that people with SQL skills from say having worked with other SQL databases, it just sort of naturally transfers over? Or is there's still some amount of learning curve to understand it at that scale that it can scale to?
Well, it depends. When you're just doing CockroachDB within a single data center, or even within a single kind of nearby geographic region, the latencies are small enough that they can mostly just, you can ignore the distribution aspect of it, and your kind of normal SQL design skills translate directly over. The challenge that we have, you can't ignore geographic latencies. They're just unavoidable. And we still need to give people more kind of guidance on how to be designing schemas for geographic replication. How do you want to partition your data? How do you want to replicate your data? Just making it more obvious. We've given people all these kind of low-level tools to do it, so you can do very advanced geographic database designs, but we're not giving you enough guardrails. So I kind of see this similar to the way, Kubernetes has evolved, where, initially before the operators, you had all the tools to, manage your applications, but there's just a little bit of a pain. And now things are becoming more and more user-friendly.
Yeah. And I think what you're highlighting is really just the evolution we've seen with its, the first is, hey, this is amazing that this capability is possible. And then the next thing is, okay, now I get sophisticated about how to use it. And then you realize like, okay, now that I have that level of sophistication or expertise, what does it mean in this new context, right? It's abstracted, it's scalable geographically. It's, stuff that you was either impossible to do or complicated to do now becomes built in. And then you start to ask yourself like, okay, what else can I do? So yeah, it's very interesting that you're seeing that evolution the way you are. The other thing I see that the database companies have tried to do, and you highlighted as well, is you not only have to provide a really rich open source community, you provide a commercial product for customers that want a commercial piece of software, and then you also have to provide them an on-demand service that for those that say, I want it, but I don't want to run it. I imagine that level of experience that you're getting from running the service comes back into the software product and the community as well.
Oh, absolutely. It's wonderful to get that experience. I just see this as a general trend in the industry, and I'm not the first to identify this. We just want to consume everything as a service.
Right.
No one runs their own email server. No one runs their own, servers at all anymore. Even more than that, they don't want to run their own database. They don't want to run their own analytics system. All this stuff is becoming services, because it takes away this, huge burden. I still have to know how to be a developer for a database, but I don't have to know how to be an administrator for it as well.
Yeah, very, very cool. Peter, I want to be conscious of your time. We're going to wrap it up there. Thank you so much for the insight, teaching us about CockroachDB, bringing your expertise to this distributed space. Folks, I will put all the things in the show notes, the ways that you can reach out to Cockroach, take a look at their service, take a look at the upstream project. Peter, again, thank you so much for the time. And folks, we're going to wrap it up. Thank you for listening to the show. Thank you for telling a friend. And we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.